Check the injective and surjective of the following functions. So we have function f mapping integer to integer. F of x is defined as x square. So basically we have minus say 5, minus 4, minus 3, so on and so forth, till, of course, this starts from minus infinity to plus infinity, 1, 2, so on and so forth. Now, at the output, what can I map? Let's have a look. So in this case, I have, integers now. So we have 0 also. And we have 1 and we have minus 1. We have 2 and minus 2, right? 2 and minus 2. Sorry, this is 2 and this is minus 2. But we can see that for an output of 9, I can give an input of 3 and also minus 3. Minus 3 also gives me 9, plus 3 also gives me 9. So all in all, what is happening? Yes, for an output of 9, I have two inputs that is mapping to it. So we have minus 3 and also plus 3. So what is this? This is an example of many to 1. So no, it is not injective. So let's write that 1 1, also known as injective. So it's clearly a case of not being injective. So let's consider for 9 belonging to say not n, z, or your domain. Sorry, in this case codomain. We have 3 and minus 3 as its possible pre-image. And so what can you infer from this? We can tell that f of x is not 1 1. As simple as that. Give an example which shows it's not 1 1 and you're done. It's so with onto also. It's so with everything actually, to be honest. Next is your surjective. What does surjective mean? Well, values that are part of codomain have to be part of range also. But here you have 9 and say you have, before this would have been 4 and 1, so on and so forth. So values like 2 and 3, 5, 6, 7, and before this all the values including minus 1 and so on and so forth. Minus 1 till infinity, minus infinity. All of these are not mapped. So how do you put this across? You just give, if we consider an input value of 3, which is part of your integer and your codomain. So I can just write that. We need root 3 as its pre-image, right? Only if I give a value of root 3, it will square root 3 and will give an output of 3. But root 3 does not belong to natural number, that is your domain. And so from this I can infer that f of x is not onto. Okay, yes. So for this particular condition, the same condition was 1 1, the same function was 1 1 and not onto when we were mapping from natural number to natural number. In this case, it's neither 1 1 nor onto.